Thanks for attending this session. My name is Graeme Rocher, and I'm going to provide you a What's New in Micronaut 3 introduction to Micronaut, and hopefully you'll be able to take away all the new things that have appeared in the latest release of Micronaut. Like I said, my name is Graeme Rocher. I'm an architect at Oracle Labs, where I lead Oracle's contributions to the Micronaut framework and work closely with the GraalVM team on new features that make Micronaut run better on Graal. So for those of you who have not heard of Micronaut, or have not used it before, it is a new application, relatively new application framework that focus on modern architectures like serverless and microservices. But it's also a complete Java application framework for any type of application. So it's very modular, and you can use it to write command line apps, message-driven microservices. We even have folks using it to write Swing desktop applications. If your Java application has a static void main and you're interested in build time dependency injection, then Micronaut may well be for you. It works very differently to traditional frameworks like Spring and so forth by instead plugging into your Java compiler via the annotation processor infrastructure. So it hooks into Java-C and essentially pre-computes the way dependency injection works in a completely reflection, runtime, proxy, dynamic class loader free manner. So there's none of that happens with Micronaut. And it has an HTTP client and server based on Netty by default, but there are pluggable servers and clients for Micronaut that for other technologies, whether you're using the servlet environment or serverless, like I mentioned before. We have runtimes for Oracle Function, AWS, Lambda, Google Cloud Run, Google Cloud Function, and many different ways to write Micronaut applications. So for those of you who haven't heard of GraalVM, it's a new virtual machine out of Oracle Labs that plugs into the existing OpenJDK's JIT, and in JIT mode is able to increase application throughput between 20 to 30% and reduce latencies for certain kinds of workloads. And it's also able to compile your applications into small self-contained native binaries, which is great for cloud deployments. These are this ability to turn applications into native images has really taken off for GraalVM, and Micronaut has great support for it because of Micronaut's elimination of things like reflection and dynamic classing, dynamic class loading, etc. It's much easier for GraalVM native image to perform the closed world static analysis that it needs to perform in order to produce a native binary. It's also able to seamlessly support multiple languages and libraries using the Truffle language framework. So there are implementations on top of Truffle for JavaScript, Python, Ruby, all the different popular languages, all running on top of a single virtual machine. And 21.3 will be out in a couple of weeks of GraalVM, which will introduce official support for JDK 17. In the meantime, you can grab developer builds if you're looking at JDK 17 support. Like I said, Micronaut has a great relationship with GraalVM in that the closed world static analysis that GraalVM has to perform to produce a native binary is a lot easier for GraalVM to do with Micronaut because of the way it eliminates reflection, runtime proxies. There's no bytecode generation, no use of bytecode generation libraries at runtime. Everything is statically loaded. There's no dynamic class loading. And once you have a native executable, your application starts up in 20 milliseconds and significantly reduces the memory consumption, which is awesome if you're looking into, for example, serverless or low memory footprint microservices, command line apps, lots of different use cases for Micronaut plus GraalVM. So let's talk about Micronaut 3 then. So for this release, Micronaut 3 has been in development for a year, and we had a number of different themes that we wish to target for Micronaut 3 for this release. One of them clearly was JDK 17 support, with JDK 17 coming out in the same time frame. We wanted to make sure we had some great support for things like records, all the new constructs within JDK 17, seal types, etc. Making sure all of it works and Micronaut is completely usable in the context of JDK 17. In addition to that, we have revisited our GraalVM support to make the way the Micronaut generates at build time different classes through the annotation processing mechanism more efficient from a GraalVM perspective. So with Micronaut 3, there is a significant drop in memory consumption, and startup time has improved a great deal for native image under GraalVM. Native image sizes are smaller. Including jar sizes are smaller, and in general, we're producing more optimized bytecode. And we expect that as new minor releases of Micronaut 3 come out, there will be more and more optimizations for GraalVM, and Micronaut will start faster and become smaller and smaller and smaller, and more efficient for native image workloads, which is really exciting as we start to see the fruition of the collaboration between the Micronaut team and the GraalVM team into making Micronaut one of the most efficient frameworks for building native applications around. In addition to that, we have part of the Micronaut 3 themes is focused on standards support as well. So I have recently become a committer on the CDI project, and we're aligning many of the features around dependency injection, which is also a theme, have been to support a upcoming release of CDI 4, which Micronaut will in the future support. And as part of that as well, we have been moving from the JavaX namespace to the Jakarta namespace. So Micronaut was already JSR 330 dependency injection compatible with JavaX.inject in Micronaut 2. We have moved it to Jakarta.inject, although we continue to support JavaX.inject as well. And it's one of the nice things about the compilation time nature of Micronaut, in that we can support these different annotation models at compilation time without adding load or complexity to the runtime. So standard support is again a big theme. And then another theme was reactive. So Micronaut 2 was heavily based on RxJava 2. But we noticed that developers in general are using different reactive libraries, and there are many of them, from RxJava 2 to RxJava 3 to Reactor to relatively newer ones that are coming out. Developers want a choice of reactive programming models and reactive libraries. So Micronaut 3 has been decoupled from any kind of specific reactive library. We recommend developers use Reactor, and we continue to be compatible with RxJava 2 if you're doing reactive programming. But we've added support for RxJava 3 as well, and opened up the choice in terms of what libraries you want to use with Micronaut 3 if you go the reactive programming route. Another major theme of Micronaut 3 was dependency injection, which is linked to the standardization efforts. So we significantly enhanced and improved the dependency injection capabilities that Micronaut includes, with features like broad support for generic type injection, support for more cases of interception, so you can intercept constructors and post-construct and pre-store methods, we broadened the support for qualifiers so that you can have multiple different qualifiers. And a lot of these features around dependency injection and improving the dependency injection capabilities of Micronaut were clearly alignment around CDI support. But the way Micronaut 3 is being built, or Micronaut is built in general, everything is compilation time, and we have to figure out the best way to support all these different features at build time, so that when you're constructing your application and during compilation, all of these features manifest in a efficient, reflection-free manner. Pre-computing only the information you need, and storing only the information that's necessary to form and wire together your application. And finally, Micronaut data is a big theme of Micronaut 3. We have significantly improved Micronaut data, and again, it's linked to the efforts around JDK 17 and reactive. Micronaut data has broad support for JDK 17 records in the JDBC module. We also added broad support for reactive programming with R2DBC. So if you're doing reactive programming and and you can combine those two, so you can do reactive programming with immutable types, mutable data classes via records with Micronaut data. So Micronaut data has seen significant improvements amongst many other features that were added to it, including support for things like optimistic locking, and better support for batch updates, batch inserts, batch deletes, etc. So a lot of different features went into the Micronaut 3 release of Micronaut data. Okay, so for those of you who have ever been to one of my talks before, I'm not one to spend a great deal of time on slideware. I prefer to let the code do the talking. So I'm going to go take you through to some of those things in Micronaut 3 and give you a brief demo of Micronaut 3. So I have a Micronaut 3 application here, and if you're interested, I'm using the Visual Studio Code with the GraalVM Tools for Java extension pack. And I have a Micronaut application here, and I've set it up to using the GraalVM extension pack to use the developer builds of Java 17 and 21.3. So like I said, this 21.3 release of GraalVM is going to ship in a couple of weeks. So you'll get to use the official release. But currently it's the only way to get Java 17 support. So with GraalVM and build native images with Java 17. So I have set that up. And this is my Micronaut application. So if you have never seen a Micronaut application before, this is the main entry point, which is just a main class where you can come in and just run it directly here, and the application will start up. And basically we start up on port 8080 by default and be exposed. So it's really pretty simple to get going directly inside your IDE. Micronaut also has a testing framework called Micronaut Test, which supports a lot of different test frameworks. So it has support for JUnit 5. It has support for Spock if you're a Spock fan and prefer Groovy testing. It has support for CoTest if you're a Kotlin user. So we have broad support for different languages and so forth. And what Micronaut Test does is quite simply spin up Micronaut in terms of an integration test and allow you to dependency inject your test and so forth. So directly from here I can get going. Now, Micronaut is extremely fast and efficient, and it's only even better in Micronaut 3 because of all the optimizations where we're seeing significantly improvements to startup time and so forth, and that flows through into the testing experience, right? Where when you run tests, this is being a full integration test that starts up the server and so forth, and it's still extremely fast. So testing experience is critical with Micronaut. But I want to demonstrate some of the new things. So So, you know, one of the things that you can do with Micronaut is define configuration properties in JDK 17. So this is a Micronaut 3 feature where I can say create a new record, and we can create it in that package. And, you know, we can say this is going to be an author configuration, like so. And that will create a record, right? Seems that I have not, see, it's not is enabled. So let me see if that is, I have not set this up correctly. It should be working correctly. So I don't know why that warning is appearing. But basically, what you can do is on any record in Micronaut 3, you can add bind from configuration. So for example, I can say this is from the author's namespace. I'm going for each property under the author's namespace, I want to bind the name property. And the advantages of that is that, you know, I can come into my configuration, and this is my application configuration here. And I can say authors Fred name Fred Flintstone Barney Barney Rebel or something like so. And I can bind configuration under the author's namespace to this record. So you can then dependency inject it. So I can say list author configuration and inject it into my test here. And we can say add an assertion here that says, for example, assert equals to authors dot size, and probably I need an import for this list, I guess, before I can call the size method. And basically, actually, it should be configuration. Sorry. So configuration is dot size. There we go. And basically, what we can do is with this in place, we can run this test and see what happens. And the test passes, right? So so for each configuration that is present here, we can bind from application.yaml. Now, the cool thing about this is it's not like Micronaut is completely cloud native, so it's not like isolated to application.yaml, the binding. So you can also define, for example, a environment variable called authors.fred.name equals you know, Fred Flintstone, and you can export that environment variable into your environment, and it will be picked up and bound to Micronaut is able to bind to different sources from different sources, including environment variables, including things like /d system properties, where you could say authors.fred.name equals, you know, Fred Flintstone, and supply the configuration from the application runtime on environment, and it will bind correctly to the correct place and so forth. So we've added like broad support for records, and you know, it works as expected. So another thing with regards to JDK 17 GraalVM and records is we have, and by the way, with regards to questions, I'll do a series of Q&A at the end. So if you have any questions for me at the end of this, then, you know, we can discuss that at the end. But in the meantime, I'll just carry on with the demo. So another thing with records we have added is you can essentially you can essentially create a new record that maps to the database. So for example, I'm going to create another record here, and we're going to call it book. Yeah, this is going to be a book record. And what you can do is you can say this map is a mapped entity, and it's got a type, for example, the ID and the title, like so. And what that does is, and with the ID, what you can say that this is a generated value, and it's an ID, and it's nullable. And that will allow me to define a record that maps to a table in the database called book, that I can construct really easily with Micronaut data. So I can, for example, create a new interface here, which is a book repository. And this can be a JDBC repository with a dialect of H2, and you can make it extend from CRUD repository with my entity type and the ID type. So with that in place, what we can do is persist some data to the database almost immediately. So for example, if I make this a singleton, and as you can see there, with this import of singleton and Micronaut 3, I'm using the Jakarta inject namespace instead of javarex.inject. So that's one of the visual ways, using Micronaut 3 by switching to the Jakarta namespace. And so what you can do with Micronaut now as well, with regards to dependency injection that wasn't possible before, is you can actually inject things by generic by generic types. So for example, I can inject CRUD repository here into my constructor of my application. Probably I need to import that first. Just regenerate that. And generate the constructor like so. Okay, so whoops. There we go. So, and then what I'm going to do next is I'm going to add a event listener that listens for the startup event. And the startup event will essentially, startup event will be triggered when the application starts up. And this will essentially, by adding the event listener annotation to this method, the on startup event will be triggered when the application starts up. And I can, for example, make this transactional like so, and make sure I add an import for that. And that will make the startup event run within the context of the transaction. I can then use my repository to save a new instance of book and pass in null and the title, for example. Let's call it learning, Micronaut, whatever it may be. Now, one key thing about repository definitions that use records in Micronaut 3 and above is that the return type will use a copy constructor approach to return book with the ID assigned. So if I were to run this, for example, and I think if I do book ID and just output that, for example, here, if I run this now, you'll notice that the ID is assigned using a copy constructor approach for the record to the resulting return value. So that's pretty important in terms of how things are set up with regards to records and record support for Micronaut. So you can see down here the ID of the book has been assigned using that to that record, which is returned from the save method. And in addition to that, we can see how Micronaut 3, which wasn't the case in Micronaut 2, was able to select the correct bean to inject based on the generic type argument. So I'm using CRUD repository here, which is a super interface that is part of Micronaut data, to essentially inject an interface that receives a book and an of type long. So if I had different CRUD repository implementations that use different entity types and ID types, Micronaut would be able to correctly select the correct one to inject, which allows you to build more dynamic systems than you were able to do so previously in Micronaut 2. So that's pretty cool. And in addition to that, with the if I didn't want to use a startup event, I could also use, for example, a post-construct event. So with regard to Jakarta namespace support, we have support for post-construct events as well on methods, which is nice. Okay, so the nice thing with the records as well is you can, for example, apply all of the different validation rules that you're used to using Micronaut's build time validation facilities. So you can say not blank, for example, and an import, and that will ensure that the title is not blank or cannot be blank, and it will apply any kind of validation rules for Micronaut data when you supply it and so forth. So, so Micronaut data broad support for immutability in records, and broad support for essentially immutable types in general. So that the support for records that we built also applies to immutable classes. So even if you aren't upgraded to a version of Java which supports records yet, you can use final variables and so forth to essentially achieve the same thing. So that's all pretty cool. Now, in terms of, I want to show you the difference between reactive programming and synchronous programming of Micronaut. So far, everything I've done has been, with synchronous programming. I've created a book repository. I have an application class that's performing an insert. So, for example, if I create a new endpoint here to expose this data, a new controller in Micronaut's terms, what I can do is annotate this with our controller like so, and add an import for that, for example, and then inject my my book repository into it like so. Generate a new constructor for that. And what I can do is with this change, just generate the constructor. There we go. What I can do is create for example, get endpoint that exposes the books, and maybe returns an iterable of book, which is clearly asynchronous data structure. So we can use repository.find all, for example. There we go. And so this is a new controller that I've defined that's going to essentially return all the books from the books URI that I'm outputting here, and expose a get endpoint that returns those books using the repository definition that we have here. So what this allows me to do, if I just run my application. So if I go to a browser and go into books, you can see that we have a single book called Learning Micronaut coming back from my application, which is what I expected. Now, because Micronaut is running on Netty, this by default will in fact block the event loop by doing a blocking call. Now, there's various ways that you can avoid that happening. One way is to define execute on here and say task executors .io and add an import for that, like so, and add an import for my execute on. And now any operations on this controller that interact with JDBC will essentially block the not block the event loop and instead run on the IO thread. You can also configure this globally. So if you know your application is going to be doing primarily blocking operations, you can basically configure the execute pool globally, and the execution, the thread selection strategy. So you can say server thread selection and then choose auto, for example. And when you choose auto, it'll actually use an imperative approach. So it'll look at this is not a reactive return type. Therefore, I'm going to automatically switch it to the IO thread pool. So we have a variety of ways where you can do both imperative and reactive programming on the same in the same environment without having to think about it necessarily. If you're doing blocking operations like I'm doing with the book repository interface here. But in addition to that, we also have the ability to and in Micronaut 3, broader support for R2DBC. So there's a mn feature diff command that you can run to see what it takes to add an additional feature. And one of those features that I'm going to add right now is R2DBC support. So I'm just going to, as you can see, when you use feature diff, it'll tell you exactly what you need to add to your build configuration to get going. So I need to add a couple of dependencies here to R2DBC to my build configuration, like so. And I need to add a R2DBC driver. And with those two in place, now I can do now I can essentially do reactive programming with R2DBC. One other thing that you will probably need to configure is to make sure R2DBC is looking at the same database. So, so in my application configuration, you can essentially configure R2DBC to point to the same database as my my synchronous database. So now I've got two data sources, an R2DBC one and a default one, and they're both pointing to the same data source essentially. Now what I can do is switch this out essentially to use a reactive repository, and there are various. For example, there's a reactive streams CRUD repository, which you can use, which will expose reactive signatures. But what I'm going to do is I'm actually going to use another repository called, and before I do that, in fact, I'm going to add a dependency on a particular reactive framework. So once again, I'm going to use mn feature diff to see how I add reactive, which is again, new in Micronaut 3, where we have decoupled the actual reactive library that you may use. So I'm going to choose to use project reactor as my reactive library here. Okay, so with that in place, what I can do now is switch my book repository to, instead of extending from CRUD repository, I'm going to extend from reactor repository. I think my ID is slightly out of sync. So RTDB, yeah. So what I'm going to do quickly before I continue is just reinitialize the ID quickly. So I'm going to close this, and we're going to open it again. And let it do its thing. I'm gonna have to make sure that I have the correct GraalVM SDK installed here and set up. Okay, so I'm just going to use that for a moment. We want JDK 17. Okay. Right, so we should be back in business there. So what I'm going to do over here now is, yeah, now it's completing. So book longs, for some reason, sometimes it gets out of sync, for whatever reason. So reactor, I'm going to extend from reactor repository. And I'm going to instead make this an R2DBC repository. And with the same dialect. So now in my application, when I inject, instead of injecting CRUD repository here, I'm going to inject repository and regenerate my constructor for that. Okay, so we need book repository. So now what happens when you call save, instead of returning a book directly, as in the imperative case, instead we get a mono back, and we actually, in this case, we can block and return the because essentially, you know, the save method is now returning a reactor mono instead of a synchronous type. So we actually have to block in order to perform the insert. But in this case, which is, you know, synchronous code. So I'm going to toggle click. And what we can do now in my controller is instead of running on executors IO, we can change the find all method to return a reactor flux, and run essentially the same code as before, but now using reactive programming model and reactor in Micronaut 3. And, you know, so this is essentially, you know, the same model. So whatever I can done here, something is not. I think, let's have a look, hold on. Probably it's this guy here. In case of transactions, auto transactions work differently with reactive. So I'm just going to run it again. And for some reason, what am I doing wrong here? Imports. So error code while writing response. That's not, for some reason this is not working now. The demo gods are not with me. But essentially, yes, with the reactive programming, you essentially can return, you know, fluxes instead of monos, and so forth. So let's actually try that. Let's return a mono list of book, for example, and collect the results. Oops. Into a java.util.list, and see if that does what I wanted to do. So no, apparently not. For some reason, I must be missing something, a dependency somewhere. The React R2BBC. Okay, well, we'll have a look at that later. But essentially, yeah, you can essentially define reactor CRUD repositories that extend from reactor and perform completely non-blocking operations in the case of my controller by invoking find all, which returns flux and mono and so on and so forth. In addition to that, once we have constructed our application, now the building native images is a lot easier, so and more efficient. So with Micronaut 3, you can essentially drop into any kind of terminal, build into a native image, and it will construct the native image of your application. And the actual built native image starts up significantly faster than Micronaut 2, and is significantly more efficient than Micronaut 2. So you can construct the native image, and native image is able to perform the closed world static analysis, and the metadata that we construct from all these classes that you define, the controller and so forth, is more susceptible to being initialized at build time. Therefore, you will see significant reductions in memory consumption, in significant improvements in performance, reduction in the size of the built image, and in general, you'll see significant improvements when building native images from your application. One thing to note is that if you are going to serialize records with JDK 17 and GraalVM into JSON, in a JSON response, you'll want to add the reflective access annotation. This is because Jackson currently requires reflective access to records in order to serialize them into JSON. And Micronaut provides a really nice way to define all of the classes that you may need reflective access in your application. Just by using add reflective access on a type or a field, you can generate the necessary reflective metadata and include it into your native image. So yeah, the built native image, starts up, really, really fast, considering this is like, it's inserting a database, interacting with the database and so forth. And in just 41 milliseconds, your application is up and running. And this is a full database application and so forth with R2DBC. With that, that is the demo of all Micronaut 3 features. We looked at reactive programming, we looked at Jakarta standards, we looked at support for JDK 17 records, and building native images that are even more efficient than normal. So in terms of Micronaut 3 plus Graal, you'll see that we have a more efficient build time metadata format that is able to, comparison with Micronaut 2, reduce memory consumption by 20%, drop startup time. So in a hello world, it goes down from 22 to 14 milliseconds with Micronaut 3, and a reduction in native image size. And throughout the course of the Micronaut 3 releases coming up in the next few months, we will be doing more and more optimizations to further reduce these numbers. In fact, we have already a proof of concept which is targeted for Micronaut 3.2, which drops startup time to 6 milliseconds. So we're focusing on optimizing all of these metrics as much as possible to make Micronaut the best framework for building any kind of application, whatever you may do. So to get started with JDK 17, GraalVM, and Micronaut, do head over to and grab the developer builds. Oops. Which are available from the GraalVM org. You can grab Community Edition developer build. You can generate a new application at Micronaut launch. So go to micronaut.io/launch and generate a new project today. Open with your favorite IDE. I was using VS Code today, but there's great support in IntelliJ and all the different IDEs for Micronaut. Check out the documentation and the GraalVM docs, and also the JDK 17 docs as well, because it's exciting to use these amazing new technologies together and start developing. So some further Micronaut 3 resources as well. You can find out everything that's new in Micronaut at Micronaut 3, and about upgrading steps of the upgrading documentation. And in summary, Micronaut 3 optimizes already heavily optimized framework for GraalVM, delivers alignment with the Jakarta standards, adds support for JDK 17, and provides another leap forward for Micronaut data with support for mutable types and records and so on and so forth. That is my presentation. I think I have time for Q&A. If anybody has questions, do shout. We have some questions in the chat. One of them is, does records work with JPA? No, JPA and records are not a good fit due to the way JPA is stateful. Micronaut data, JDBC and RTDBC are both simple data mappers that maintain no state, like contact with a persistent session and so forth. Because of the way the JPA is a full OR object relational mapper with associations and the requirement to implement equals hash code, it's not a great fit for using your entities with records. You can use DTOs with JPA and records. So that is one use case. If you're using a data transfer object, you can combine it with JPA, but in general, records are not the best fit for JPA entities. You can use them with DTOs, as far as I'm aware. And another question is, does the startup time depend on or vary based on specific hardware or OS? So yes, the startup time will always depend on the hardware, but GraalVM provides optimizations for all hardware and all operating systems. So I expect if you run the native image on a slower machine, it'll start up slower, but that would be the same for the Java version of the application, right? It will also start up slower. And actually, GraalVM allows Java applications to go places where they couldn't necessarily go before. So, memory and CPU constrained platforms. When you build a native image that starts up much faster and natively and consumes less memory, you can take that application places where it couldn't necessarily run before, such as IoT devices and so forth. See if we have any more questions. I'll wait around a bit longer and let me know if you do. So there's a question here that I missed. What is the best way to migrate projects with multiple dependencies written in Micronaut 2 to Micronaut 3? One thing I didn't point out with regards to the upgrade docs is we have a great section on upgrading to Micronaut 3. And one of the innovative things we did with Micronaut 3 was also provide automated upgrades through Open Rewrite. So you can, there aren't many breaking changes in Micronaut, but Open Rewrite will help you address them. So the main one being like the JavaX, the namespace change. And you can add the Open Rewrite plugin and run rewrite, dry run, rewrite to kind of stage the changes. And it's basically will do refactoring of your code base. It'll read all the imports, do all the changes needed to update, and basically automate like 80–90% of the upgrade that you need to do into just a single command, which is rewrite run in either Gradle or Maven. So yeah, this is the first time we've done this where we've actually provided automatic upgrades. I don't think it doesn't handle every single case, but it handles majority. So if you have a large project, this will get you like 80–90% of the way there. And then, it's just hopefully a matter of tweaking. Like I said, there's not that many breaking changes in Micronaut 3 compared to Micronaut 2. It was mainly the JavaX and RX Java shift that has changed. So any other questions for me? Oh, look, there's one more. Are there any examples available for Micronaut with Kotlin on Azure functions? So I'm not sure if we have a guide, but what you can do is you can go to micronaut.io and you can click launch. And what you can do is choose serverless application and then add Azure serverless. Then you can choose Kotlin as your language. And if I click the preview button here, you will see it's going to generate a project for me with Azure and Kotlin and so forth. And with all the kind of Azure function configured for me. If I had chosen Maven, it would have done Maven, but basically it generates everything, an example for me with that's ready to deploy to Azure function. So Micronaut launch is a good, reference application builder as well, which might help you get some of the way there. But I do acknowledge it's an area we need more guides on how to build Azure functions. But I hope that helps anyway. Okay, so I think that is everything. Thank you very much for attending this session. I hope you enjoyed it. Live coding is always fun, even when it doesn't always go to 100% to plan. And yeah, I hope to see you at my next session on Thursday, where I'll do actually a multi-cloud serverless talk, which should be a lot of fun as well. Thank you all. Thanks a lot.